utility company, and myself, CEO of Sterblue, Nicolas Drabert. So we're going to walk you through the different steps of how to conduct automated distribution grid inspections with drones. What is the context? Why we are using? Why we need to perform inspections of the distribution grid? What are different use cases of drone application on the distribution grid? Then the DJI drones, how are they used today in practical situations for such inspections? Now we're going to introduce after a live demonstration of the Sterblue solution, so walking you through the different steps that allow the software to perform inspections. And then we'll have a customer story from Enedis, Christophe Guenin, how they are using Sterblue today. And I'll also myself, from the Sterblue side, walk you through an operation so that you have a practical case in real life, how does it work. Yeah. And we'll finish with Q&A, so don't hesitate. You can ask questions at any time. Please write them down, and we'll of course make sure to answer most of them.
Oh, Nicolas,
you want to take?
Yeah. Hello, everyone. Someone in the room told us that they didn't have the sound. I mean, is that the case for everyone, or?
Right.
I mean, if someone else can. Oh, wait, someone else still. Okay, perfect. The sound works. Sorry. So this is just one person that probably need to fix. So this is at the bottom left of your screen. You can manage the sound of this conference.
Yes, you can share your screen if you want to.
Yeah, sure. So I'm gonna continue the presentation from there. Sorry for that. Yeah, so we have 5 people today as presenters. So we have Vincent Lecrubier, which is the Chief Technical Officer at Sterblue. We have Eric Razon from DJI Enterprise, Marketing Manager for Europe. We have Nicolas Drabert, the Sterblue Chief Operation Officer. And finally, Christophe Guenin from Enedis, the Deputy Director of Asset Management in the Bourgogne region, that will carry out a testimony at the end of this webinar. And myself, I'm the Sterblue CEO. So yeah, just to give you a quick brief on the distribution grid market and some key facts. So that will be the first point. The second point is to go through the stakes and pains of the distribution grid inspection. And finally, we will compare different existing solutions with pros and cons. So we will build up some different scenarios just to be clear on what we compare, and we'll go through it. So just 3 key facts which are kind of interesting to see. The first one is there are more than 30 million kilometers of distribution grid in the world. There are more than 600 distribution system operators in the world. And just in the US, we have more than 600 small local distribution system operator in the US. So just to mention it. And finally, just one figure which is really important. After the wildfires in 2017 and 2018 in California, today PG&E still have a $30 billion liability for the insurance companies. So a couple of key facts. So today the pains of the distribution grid inspection. Definitely the reason why it is inspected today is to ensure safety, to ensure the performance. One of the criteria to assess is to minimize the outages, manage financial provision in case of big event, post-storm event, something like this, and in the end manage legal claims. So if there are any accidents, the important is to prove that the utility had properly inspected the grid or carry out the operation, the maintenance operations. And there are obviously some strong changes in these different objectives. There is, I mean, the volume of operation and traceability is really high and needs to be kept all along the process. The utility companies are mainly looking for some reproducible methodologies to inspect the grid, to compare the inspection year over year, to make sure that we can see the evolution of the main problems or the problems on a whole line, for example. The last challenges that they have is to make all their tools integrated in order to ensure the good asset management in the end. So a couple of, now if we go a bit deeper in the type of defect that we can encounter on the distribution grid. So obviously this infrastructure are outside. So there are lightning strikes, corrosion, moisture, vegetation, rain. There are also, foreign interventions. You can find some animals like eagles, some rats, some small animals that damage the grid, and obviously some humans. For example, if you are in a field, you can have some vehicles that hit the poles. There is also the wind, obviously, and some manufacturing problems that can create bigger damages in the end. And all of this creates, obviously, some damaging situation that impact the performance and safety day over day. So the corrosion, obviously, the broken components like broken insulators, broken cables, some contact with vegetation that can trigger some wildfires that can also, create some other damages directly on the grid. We have also some worn fasteners that could make the line fall down the ground. And another example could be the woodpecker holes for the wood poles actually, and which is a big challenge for the health integrity of the poles. Real quick, so the goal here is to give you a big overview of the different use cases that can be addressed with aerial inspections. So the first one is actually the detailed inspections. So it means it can usually be used when you want to extend the lifespan of your grid. And this is actually one of the use cases that Christophe will introduce at the end of this session. And this is also one that Sterblue did a lot in its previous operations. So the goal is definitely to cover 100% of the assets and to take the right decision afterwards. The second one is the vegetation encroachment. So the goal is to know the distance from the line to the cables and take the right vegetation trimming decisions according to that. The next one is emergency inspections. So if you have a storm or if you think that you will have some strong wind in some really hard wildfire conditions, you can decide to stop the grid in order to protect the population. And this is actually what happened in California quite recently. Some recurring inspections. So you take one picture as soon as you see a problem, so you fly pretty fast above the grid. And the goal is just to notify the main problems on the grid. There is also the mapping that can be used, for example, if you want to design, build a new line, that is really interesting to know the exact terrain of your on the area you wanna build or you wanna design in your line. And finally, another use case identified is the post repair or quality control. It means, for example, if you change some equipment, if you paint a new pole or whatever. This is interesting, to control the job of the contractor to make sure it complies with the initial requirements. So just to compare now 3 different solutions and scenarios in the meantime. So the first one that we have chosen to assess is a scenario where you have an helicopter that takes pictures. There are 3 people on board, 1 person to take pictures, the other to guide the pilot and the pilot himself. And the deliverables are mainly, Word documents or Excel files, and you store the data in some organized folders, let's say. The second scenario is pretty much the same, at the difference where you use some drones, some off-the-shelf drones, and you still have the same data management process in the end. And the last scenario is one scenario where obviously you use a lot of software in the loop. And you provide some online deliverables with some analytics capabilities in the end. So if we compare quickly these different solutions, so today if we take the scenario of a really detailed inspection, so it means 100% coverage of the infrastructure, and this is really important because the performance will be pretty different if you take one inspection use case or another. So if we take this highly detailed inspection, it will cost you around $20 per pole to be inspected. And some ground visits could be needed just because you cannot fly everywhere with an helicopter. Sometimes you need to do some ground visits to make sure you cover all the infrastructure. The second solution is around $17 per pole. It's actually the manual process with the drone and with the data management. So there is a high deployment flexibility because you can rely on a strong pilot ecosystem, drone pilot ecosystem. But there are some challenges to manage and monitor high volume of inspection. And the last one, if you inspect with a bunch of software along the way, you gather the best from the manual and fully automatic inspection, and you have a really seamless process along the inspection. Regarding the scalability, so definitely the helicopters does the biggest volume of inspection per day. In this case, we can inspect up to 800 poles a day. But in the meantime, if you want this activity to be scalable, you need multiple heavy local investment. And there is still poor post-mission data management, which make the scalability okay, but not amazing in the end. The second point is the manual drone with manual data management process. Low scalability, even with strong pilot ecosystem. This is really poor and long to inspect that way, and also a poor post-mission data management. And in the end, with the software, so we are kind of intermediate. We have a scalability because the performance is improved compared to manual flying drones, and we have an easy post-mission data management, which make the scalability quite interesting. Data management, so definitely for the two first one, not easy. I mean, that works. UTT companies can work that way, but on the long run, you cannot build something incredibly serious based on this absence of tools actually. And obviously, if you have some software in the scenario 3, you can you manage millions of images of data to make sure that you will organize everything for the future. You will be able to compare. You will be able to trace everything for the insurance company, for example. So definitely, we see a strong value here. And the last point is building a predictive management system. So again, the two first options don't allow to organize and to build the right predictive models, because if you don't have a really highly standardized flight planning, or if you don't have a really high standardized way of structuring your data with the right graph, you don't have the capability in the end to build this predictive model. So this is highly important here to have some software that allow you to build the backbone of your data system. So I'm gonna let Eric from DJI introduce the drone that can be used for distribution grid inspection. So Eric, can you share your screen? And you want me to continue that way?
Yeah, maybe Geoffrey, you could share I could change the screen, switch the screen to mine.
Okay, sure. Yeah, go ahead.
I'm not able to do it at the moment when I'm trying to. So maybe you could just control it from your side if it's okay.
Sure, go ahead. That's fine.
Okay, so for those who missed the introduction, I'm Eric Razon and I'm the marketing manager for DJI. I mainly look after Europe. While many know DJI for our consumer drones such as the Mavics and the Phantoms, the role of drones have evolved. And from travel or aerial filming to boosting efficiency, enhancing safety and operations. So at DJI, being customer-centric, that's our philosophy. Hence, we formed DJI Enterprise to develop drone solutions for a new generation of work. So aside from the drones, we also have payloads. Chopper. We also have payloads and sensors, and particularly for energy, the most sought out payload would be the Zenmuse Z30 because it has up to 30 times optical zoom. And finally, software. It's crucial for smarter data gathering. On the next slide, you will see an overview of the different drone solutions that we have for DJI Enterprise. So there's Mavic 2 Enterprise series. It's mainly used for public safety, while Phantom 4 RTK, that's for surveying and mapping purposes. And the Matrice 600 Pro, the reason why we named it as such is because it has 6 motors, and it can carry up to 6 kilograms of payload. We have the Agres for agriculture, and finally Matrice 200 Series V2, which is the most adaptable drone platform that we have in the market. Um, on the next slide, however, you will observe that as we look at the market, the customers nowadays are not only using our enterprise drones for their use cases, but they also use consumer drones. And for this webinar, we're going to take you through the Mavic 2 Pro, why it is an ideal drone solution for grid distribution inspection. So to take you through the features, it has the Hasselblad L1D20C camera. Next, it has the 20 megapixel 1-inch CMOS sensor. So both these contribute to gathering high quality images when you're doing your inspections. Notable as well is that whenever you're going to inspect in when you're conducting inspections, the interference might be bothered, and the Mavic 2 Pro has auto switching from 2.4 to 5.8 gigahertz transmission. Next, it also has omnidirectional obstacle sensing. So this means like when you're inspecting distribution grid, there's a lot of cables that may get in the way, or trees, or areas where there's strong vegetation encroachment. And with this feature, drone is able to have that added layer of protection from these factors. And finally, it has 31-minute flight time. I guess like overall, the Mavic 2 Pro is also small and compact. And when these inspectors do their inspections, the area that they're inspecting is quite big. So it's important that they have a drone that they can carry with them as they travel from different inspection areas. So going back when we were taking you through the entire components to build the drone platform, I mentioned that software was crucial. And at DJI, we built our SDKs to empower partners like Sterblue to leverage drone technology and create unique solutions for specific use cases. In the next section, I will turn it over to Sterblue. They will talk about how they integrate their software so that our drones are able to be autonomous, which has been a long desired resource of the industry. So over to you, Geoffrey.
Yeah, thank you, Eric, for this presentation. So I'm going to let Vincent, our Chief Technical Officer, introduce you a small demo. So Vincent, can you get my screen? Or?
Yeah, sure. I think I can share. Yeah. Up. Perfect.
Perfect.
Okay, so you should now be able to see my screen.
Yeah.
There's a Y connection on the grid. So the drone is taking care of that and capturing the images from all angles. You're able to adjust all the settings. The same way, if I go forward, we will inspect all pylons in a similar way, turning around each pylon and going to the next. Okay, so for one simple pylon, here is the idea. You arrive at the pylon, turning around with the required setting, capturing the right photos, and ensuring good data quality. Nicolas will be able to answer a question about productivity of the drone solution just after my intervention. Once this is done, the drone operator arrives back at home, connects on the Sterblue Cloud platform, arrives on his dashboard here. From there, he's able to access the list of missions. So he's able to see all the missions that he has prepared and planned, the ones that are executed and the ones that are still to be done. And from there, if you select a mission, you arrive on the mission page. The mission page replays here the process we've been talking about. So operation, selection of image, list of detections, list of anomalies, and finally the final report. When you arrive on the page of a new mission, you start with this. Some steps are disabled because there are no image yet. So if you select the operation part, you're able here to have a big upload box, you just drop the content of your SD card in there. The image are then uploaded, and you're able to see the image. Sorry. You're able to see the images in the selection page. So the selection page has one line for each pylon and allows to select the images that you want to keep of each pylon. So images are taken with different settings, and you see all the different images for each pylon. They are sorted by pylon automatically, or this is done automatically based on the metadata coming from the drone. So following this, you have uploaded images. You have some detections that are created automatically thanks to the artificial intelligence based on the images. So yeah, this is an example of the selection page where the AI automatically selected some images to keep. So the images on top, the red ones are the ones that we don't keep for analysis. The green one are the ones that were selected because they have good quality from the right angles. So you're able to see each image. So for each pylon of your grid, you have a big list with all the images. This is all done automatically. From there, once the AI has run, you're able to see the result of the AI run in the images. So here's an example. It's a little tutorial page, sorry. So yeah, you can select an image, go on it, zoom on it to get more details. Okay, so here I can see that the insulator was detected automatically, correctly. This one has no problem. We can see that the crossarm was also detected. The concrete pole was detected and marked as such. And yeah, the string insulator are detected correctly, and there's no problem. If the AI finds a problem, the detection are added to the list here. And you're able to see a list of anomalies. Oh, sorry. Here we go. So here is a list of anomalies on the mission. So you can see that, for example, in this case, on this image, the anomaly found some used clips and shackles. So I'm able to click on this anomaly. This anomaly is visible on only one image. Sometimes detection are visible on several images. And if I zoom in, I'm able to see that, yeah, in this case, indeed, the AI found that the shackle is used, and you can see that yeah, it's worn down quite a lot in this case. Another option that I quickly passed over is that the images are also visible in 3D, in the 3D view around the pylon. So I'm able to see for each image which angle it was taken from, and navigate like this between the images. All right. So yes, the quality that we are able to get with DJI drone is really good. This is with the consumer level drones, but yes, the quality that we get by flying really close and really precisely around the infrastructure gets really good. Finally, in the end, once everything is analyzed, you're able to go back to the mission process and get the report. From there, you're able to export the report in several formats. Sorry, this is not on the right platform. So the report is available in several formats. The first one is a PDF report. So in this case, this is a report of an inspection on a line. So yeah, typical PDF report with a quick overview of the mission. This is all the pylons that are inspected in this mission. For each pylon, you have a quick recap of the defects that were found. And then scrolling through the report, you have a list of infrastructures that were inspected, and for each of them, if there are some issues that were found, you get a recap. So in this case, this pylon, like there's one problem that was found here, and you're able to see the details of the issue. In this case, it's wooden pole decay on top of the wooden pole. So this is for the PDF export, and we also offer a CSV export, where you're able to export all these of defects as a CSV file. Okay, that's it for the demo for now on my side. We can come back to this during the question session at the end of the presentation if you're interested. Thank you very much. I'll let you the control. Yeah.
Yeah. So thank you very much, Vincent. Yeah, so now Christophe Godin from Enedis, which is Deputy Director Asset Management, will tell you a bit more about Enedis, the company itself, the drone program management that they've been leading for more than 5 years now, and also what we've done together with Sterblue. So Christophe, I let you introduce yourself and all these different points if you want.
Okay, so I'm Christophe Godin, head of the asset management and engineering division of Enedis Bourgogne regional unit. And in asset management, we have a focus on our overhead line networks, because the performance of our overhead line networks is a key point for the quality of supply we provide to our customers. And so we started to use drone for expansion, in fact, several years ago. But at the time, it was some more specific and somewhat optional. And 2 years ago, in 2017, we took a significant step in the use of drones. And this step was to use the drones for the detailed inspection, you saw, and detailed inspection for our overhead line life extension program, which is a major program for us. And in our region, it stands for 800 kilometers of detailed inspection per year. Okay, so at first we start with manual inspection, with manual drone flights, with our workforce, and we train 10 operators. But we are in fact committed to take benefit, full benefit of new technologies, which such as drones and artificial intelligence. And this is why we searched for a startup, and we contacted and started to work with Sterblue to move forward on drones and artificial intelligence possibilities for inspections. So we launched a POC, and you saw the main results in the presentation. We have two main goals. The first part was to develop the automatic supervised drone flights, and so Sterblue developed successfully the solution, which trained also our operators to use this option of automatic supervised drone flights on the field. And we asked also Sterblue to perform half of the inspections by themselves. So the testimony, this part is a success. We have a good performance, and this improves both the speed and the quality of the inspection of the picture we need. And the second part was to explore artificial intelligence for inspection. So we provided an initial database for the supervised learning, with a lot of picture, with anomaly, and the analysis by our experts. And on this basis, Sterblue trained more and more its artificial intelligence program, detects successfully false anomalies. And as a result, it works very well. For example, so pole defects on concrete or wood poles in really good, and it's very promising. To conclude, where we are today, we use the Sterblue automatic drone inspection yearly, so to inspect our lines for our line extension. And we use then the result of the inspection in our line platforms in Sloan, where our experts perform the diagnostics, design and define the works to be done, the investment for the next year. And tomorrow we expect the use of artificial intelligence to facilitate and to standardize progressively the inspection, the diagnostics results for detailed inspection flight for investment, or the standard inspection flight also for standard maintenance. So basically, this is my testimony.
Okay, thank you very much, Christophe. Just to let you know to the audience, how many pilots do you have at the moment in France for NADIS?
Oh, yeah. In France, this project is becoming a national project because we have around 20 regional units on 25. The total number of regional units is 25, and we have 20 involved. So it's really accelerating.
Okay. No, perfect. Thank you very much for this. So now the goal is just to introduce you a large operation story that we have led at Sterblue on the NADIS grid actually, and so I'm going to introduce you. So Nicolas Draber is our Chief Operation Officer. So Nicolas, could you tell us a bit more about this large mission that we have performed with NADIS in the year 2019?
Yes. Yeah, so we wanted indeed to illustrate what we showed you up to now on a concrete use case. So as Christophe mentioned, we work on a yearly basis with NADIS, and in this regard, we inspect 800 kilometers of grid, and there are 3 steps when we deploy a new customer. The first step is the preparation phase. We need to understand basically your need. Do you need like high quality pictures on every pole, or do you need like more like quick inspections in case of emergency? So this is the first usually question we ask you. What kind of use case do you need drone for? And once we have this, then we can get your data. That means we ask you what kind of information you have from your grid. If you have LiDAR, then we are able to display it, as Vincent showed you on a platform. If you have only GPS coordinates, we can also work with this. So this is basically the preparation phase. Also, we always comply with the local regulations, so all the airworthiness rules. And basically, we ask you usually also questions: what is the average span between poles? So with the local regulation rules, the average span, we are able also to give you some estimated productivity that our software will provide. So here, what you see on the map is the red dots are lines that needed to be inspected in the frame of high definition inspections. And so we're going to illustrate more particularly, okay, once we have this information, how we work inside the operations team using Sterblue software. So now that the preparation phase is done, so we have received the data from the utility company, and we have understood its need in terms of image quality, we can move on to the next step, which is the deployment on the field, the data capture. So you can go to the next slide, Geoffrey. Yeah. So here we see one of the lines, so one of the red dots that you had on the previous slide. So this line here is more or less 60 kilometers of grid, and we need to inspect all the poles along this line. So every blue, green, and purple marker represents one pole, and we need to take 6 pictures for every pole. So then what is done, we have a very pyramidal organization inside the operations team. We deploy a team of pilots on every line. Every line is splitted more or less, depending of course of its length, but every line is splitted more or less in 3 zones, and each zone is taken care of by 1 pilot. This has the advantage that no pilot is left alone in the wild. So in terms of safety, it's good. In case there are any issue, there's always 2 pilots which are close by that can quickly come for help. And it also has the other advantage that based on the estimated productivity, we are sure that we can finish the inspection of a line within a week. And that's important in order to respect the delivery schedule that we commit to NADIS. So that means here this line was having a bit more than 600 poles. So if 3 pilots are working on it, there are 200 poles. The daily productivity of a pilot is between 100, 150 poles, depending on the terrain and the drones they use. So that's the figures we are seeing right now. That means that we are sure that we'll be able to finish one line like this within 2 working days. Okay? That means that even if we have 3 days of rain, which happens in France, then we are sure we're going to respect the schedule of delivering the data by the end of the week. So here for the specific line, well, the pilots usually are using the Mavic 2 Pro, which are providing a better range than what the Phantom 4 Pro was providing for same picture quality. And one important note, if you want to perform drone operations, your pilots are going to need a lot of batteries. Okay? During a day, they usually need each 10 to 15 batteries per day. So either they have some spare in the trunk of their truck, or they are able to recharge on the field. Okay? And in terms of data, well, for this line, that was more or less 4,000 pictures, so 40 gigabytes. One thing I did not say is that all the pilots are certified. That means whether it is your pilot inside the utility company or some external pilots who will come to help to perform the inspections. We have a drone program. We have developed a drone program, and we're able to certify them. That means we are sure they'll be able to use the Sterblue software for the preparation phase and the data capture phase. And they'll be also they'll be understanding what is the requirements in terms of picture quality by the utility company. Advantage is that at the end of the day, you're sure that all the pilots are delivering the same quality as they are using the same software with the same settings. And then once, this is what Vincent explained, once this is done, so basically the pilots are finished, they have captured all the data, then there are 2 possibilities. Either they are able to upload the images themselves. For some of the lines we inspected in France, it was in the countryside, the internet connection was not good. So one solution which was doable was that either we are waiting to upload once per week. So when the operator is basically going back home, he's able to upload, or he was sending us some USB stick. But of course, if you have good internet connection, you're able to every night upload the picture by yourself. And then that means you can kick off the data processing process straight away. So yeah, so the data upload is depending, of course, on your internet speed connection, but it's fairly fast if you have a good connection. Then in order to generate the reports, you have to count for more or less 1 day. Okay, so that's the time basically for the AI to run and then to perform some quality check. Right? So the process by itself is very streamlined. From the moment the inspections are finished, you can assume that you'll be having your inspection reports in the next days following the end of the flight.
Thank you very much, Nicolas, for this introduction. So we're gonna come to the question, the Q&A. So feel free. You have a chat normally in this the Zoom software. So feel free to ask any questions, and I will allocate the question to the right people, to the right presenters. So wait a sec.
I can answer the first one that I see here. How many days is your training program? So we have 2 training programs. We have one for the drone pilots. We have one for the people who are working on the platform, more on the data processing part. For the pilots, the training program lasts 1.5 days. So that's the time basically to go over the software, and also the time to perform some flights in order for the pilots to feel comfortable using automatic flights.
Then we have a question. Please explain what flexibility has the Sterblue software to integrate with existing inspection processes and deliver actionable data. So maybe Vincent, you wanna take this one?
Yeah, so sorry, I'm reading the whole question. So the question is, given the large amount of data, raw imagery of all data that result from the analysis, are the client asset and maintenance management system generally capable to make effective use of this data? If not, how is the value realized? So yeah, in the end, Sterblue takes an approach of doing end-to-end processing. So from before the actual flight of the drone to the end deliverable, we take the option of delivering value all along the way. So the data that we give you in the end are actionable already, whether it's a PDF report that can be used to plan and perform repairs, or the CSV reports that can be imported in the client's system to our API for even deeper integration. We offer several integrations. So there is a Zapier, which allows to directly send by email the reports and a notification of new problems by email or by any other event system that you can integrate with your system. Or directly our API, which can be connected to any system, including data analytics, or any maintenance program. For large enterprise customer, we can do some customization. So please get to us for more information about this.
So another question for Nicolas. How many kilometers per hour can be inspected with the drone? So if we take the example of the detailed inspection that we performed today, Nicolas.
Yeah. So yeah, we measured ourselves. So of course it depends of the terrain and how the grid is organized. But to give you like a good productivity for us is when you're able to inspect 5 kilometers per hour. So that represents more or less 50 poles. Otherwise, you can take as an average per day to have a productivity of 150 poles, more or less, to 250, depending on the distances between the different poles. That's 100.
And second question for you, Nicolas. How long? How many days is the training program?
So yeah, the training program takes 1.5 days. So that's the training of the pilots, and then the experts themselves, if they want to work on the platform, that's a 1-hour training. As you could see on Vincent's screen, it's a very straightforward platform to use.
Question for Vincent from Matt. Cloud system available for AWS or Azure on the US mainland, or even on premise storage?
Yeah, absolutely. So our cloud system is pretty flexible. So yeah, it's definitely it is deployed in the cloud at AWS with all the certifications that you need as a utility regarding data safety and compliance programs. We are also able to deploy on-premise for large enterprise customers if needed. So again, for on-premise deployment, come to us and the sales team can guide you through that without problem.
And one question for you, Vincent. What about using thermal camera? Is your application can process thermal image?
Yeah, so thermal imaging camera is something that we have the technology to process. As of today, to be honest, we did not use them in production systems. We did not have this use yet. It's definitely something that we have tested and experimented with, and that we are able to integrate in our process. If you have specific needs, we'll be happy to explore the possibility. It's something that we're ready to do as of today technologically.
And I'm going to take this one. So are you planning to use hydrogen fuel cell drones for longer operational flight times? So my answer will be yes. But we're also looking, first of all, for something highly deployable. So if it's easy to put on site and to inspect super easily the same way that we do today, yeah, that would be definitely a good option. Maybe a question for Nicolas. How do you avoid obstacles during the automated overfly, dangerous tree vegetation? So how do you manage obstacles in the way?
So yeah, we always say we have 3 levels of obstacle avoidance. The first one is the drone itself. As you know, DJI drones have a very efficient obstacle avoidance system. So that means they can in real time detect obstacles. It works well with trees, but don't assume it will work with cables. They are too thin, but it works well with trees. Then the second layer of obstacle avoidance are the trajectories themselves. They are computed to avoid the vegetation. In case you have LiDAR, we know where the vegetation are on your line, so we can also compute trajectories which will go around them. And the third layer is the pilot. Of course, the pilot has a video feedback all along the flight, and so he can always pause the automatic flight or take back manual control if he needs to.
Okay, thank you. Maybe I have 2 questions here. So the first one is, how do you deal with RF interference, video feed and drone flight stability and transmission grid above 280 kV in grid? And we have a similar question. How do you handle more complex towers like the one used for higher voltage, 420 kV? My answer will be first to say that there will be a third webinar dedicated to transmission towers. But yeah, I mean, Nicolas, you may answer the interference questions for the distribution grid at least.
Yeah. So it's no surprise indeed for high voltage towers, magnetic interferences can be a major issue. But as you know, DJI has the matrix 210 RTK, which is resistant to those interferences. So this is the drone we use for large towers. And indeed, as Geoffrey said, we'll go into more details during this webinar. In terms of trajectory, there are differences. In terms of picture expectations, so there are other differences. So yeah, we'll cover this later on.
And Vincent, can you take the question about how do you manage higher voltage towers, like transmission, in a quick?
Yeah. So as you said, we have a webinar coming on this topic, so keep up to date. But yeah, the trajectory I showed you, for example, for distribution, is very different to the trajectory we use on transmission. The trajectory on transmission really fly around and even under the transmission tower cross arms, for example. So yeah, since transmission towers are much bigger, the trajectory is much more complex, but this is also something we tackle.
And another question for you, Vincent, actually. Do you provide a software with the settings to identify the structures, the faults, and the damage elements, or the customer has to do this setting?
No, so yeah, the software actually detects both equipment and anomalies. So depending on your requirements, we set up the software to detect exactly what you want, whether it's structure or anomalies. And this can also be done with images coming from other data sources, such as helicopter pictures, which can be processed through the same data pipeline.
Yeah.
I think I would just add something. I think it's an important point indeed. We are using each time the defects referential from our customers. So Christophe and Edis provided us the list of defects they wanted to detect on their grid, and our platform is able to handle different defects categories depending on the customer.
We have another question. Maybe Vincent or Nicolas, probably Vincent. What are the requirements for the point cloud in order to create the route, the flight planning?
So there's not much requirements actually. Even low quality point cloud are good enough. The main requirement though is that the point cloud is georeferenced properly. So the density of the point cloud is not that important. We don't need colors or anything. We do require though that the point cloud is georeferenced correctly, because we use the point cloud, as you saw, partly to plan the trajectory. So if the point cloud is not in the right GPS coordinates, it's a problem.
Yeah. So there is a question, will this webinar be available to view in retrospect? Yes, this webinar will be shared on the Sterblue website, and we will also send it by email to every participant. Another question, how do you sort, sorry. Yeah, interesting question. Vincent, how do you sort photos on parallel lines with structures next to each other? This has always been an issue. We usually have to do this by taking a sky photo as an indication. We're inspecting the next structure or else you don't really know what structure you're looking at.
Yeah, so we have actually a pretty advanced algorithm working in our platform for that. So basically what we do is, given the information that we have about the grid, whether it's from running the AI on images or from previous data that we have, including LiDAR data, for example, we create a 3D scene of the place that we inspect, including the pylons, the insulators, and everything. And we project that 3D scene, like, let's basically the same idea as augmented reality. In augmented reality, you have your image that is overlaid with some 3D elements. It works the same way, basically. We project the 3D elements in an image to figure out what is in the image. So we can precisely tell you that this photo sees this part of this pylon and this side of this insulator and so on. we're reaching pretty high precision on this because everything is modeled as precisely as we can with the data we have.
Then we have two questions from Nicolas. So the first one will be, has the drone be always in line of sight with the pilot?
Okay, yeah, so this depends, of course, of the country where we operate. So in France, we are authorized to fly beyond line of sight up to a limit of 1 kilometer, 0.6 miles. In other countries, it's not authorized, so that's a country per country decision.
And another question where we could mention integration is that has the mentioned UAV do have wide-angle lenses and single frequency GNSS? How close do you plan automated flights to the poles to keep enough security and distance? And which resolution of on the object do you realize?
Okay, so to give you an order of magnitude, on distribution poles, we fly more or less 2.5 meters away. So that's very close, taking into account that GPS coordinates can be accurate up to 3 meters. So you can already imagine that we have some tricks in order to enhance those GPS accuracy. But yeah, in average, when the drone takes a picture, it is 2.5 meters away from the pole. And that means we have usually on the kind of insulators that Vincent showed you, a resolution we terms in terms of number of pixels in more or less 300 pixels, 300 to 400 pixels per insulator. So it allows to see defects which are 1 millimeter or less.
And another question for you, Nicolas. Are all inspections missions completely automated?
So today the pilot has the hand on the camera orientation. So the trajectory is completely automated, and the pilot can at any time say where he wants to orientate the camera. Yeah? So that's basically what he needs to do. We have also worked on making this automatic, but feedbacks from the pilots basically have shown that they preferred having the hand on the camera orientation.
We have a question, I'm going to take it actually. Basically, does Sterblue provide a work image service that is tailored by a customer who recognizes the defects, a human or the software? So actually today we propose the software in SaaS, so we can train directly the pilots among the utility company. Or we can also provide a full scope service with, as Nicolas mentioned, with some drone service provider, which are qualified, which are certified to our software. And regarding the defect analysis, today we have a combination of AI, as Vincent mentioned, and we keep the experts in the loop to make sure that we have a consistent and strong report in the end. So maybe your last question, we still have 1 minute. Sorry. Yeah, Nicolas, maybe where are you providing the training certification?
So today it depends a bit of the scale of the operations we need to deploy. For large scale operations, the training can happen on your premise. So on your school grid, some utility company have this, or on your grid directly. So we can move, one of our trainers can move to you. Or for smaller scale operations, we have 2 training schools in France and in the US, and then definitely then we can train also your teams over there.
And one quick question, and that will be definitely the final one, and we'll try to answer to every question by writing the answer after the webinar. Nicolas, how do you select the best 6 pictures out of the whole set that you captured today?
Yeah, so basically the drone, the trajectory, as Vincent showed, is computed in order to trigger the pictures at the right positions. So that means we only have, in average, we have no more than, let's say, 8 pictures per pole. And then the image selection is done by the one which is precisely looking at the asset. As Vincent showed, we are able to precisely know not only to which pole each image must be linked, but also what is seen on each picture. So on a picture where we will see only half of the pole would not be selected.
Thank you very much, everyone. And so first of all, we will share this webinar on the website after in the next days. We'll try also to answer every questions that we couldn't answer right now. And thank you very much again for participating. The next webinar will be probably end of the year, beginning of January, and that will be around a transmission tower inspection. So we will definitely reach out to you to propose you a new participation. Thank you very much again, and have a good day, morning, or evening. Thank you. Bye.
Thank you.
Thank you. Bye.
Thank you. Bye.